Good to go. All right, what's up, everybody? I'm Paul. I work for Red Hat on...
Oh, yeah, you got to pick one.
Finding the mic. Test, check. All right. Yeah, I'm Paul. I work for Red Hat on Kubernetes and on Service Catalog and Open Service Broker API.
Great. I'm Chip. I'm the CTO of the Cloud Foundry Foundation. And we're here today to talk a little bit about services, catalogs, and the APIs that make them work. Cool. So we're going to start with a little calisthenics, although half the room is standing, so that's a little strange, right? I was going to say, yeah, let's get some energy going. Everybody raise your hand if you develop applications that use something like a database. Oh, good. Keep them up. Keep them up. Keep them up. Come on.
Keep them up.
Come on.
So lower them if you do not use a service like a... Is this going? Am I going?
No.
Use a podium one.
Yo. All right, great. So put them down if you do not use a service like a database, message, queue, cache, or SaaS product.
Yeah.
I'm still seeing a lot of raised hands.
Yeah. Like, I mean, that's most of us, right? Okay, everybody tired? You can put your hands down now. That's good. That's good. Cool. So one of the interesting things is, how do you actually get access to that database that you're using for your application? I mean, this is the traditional way, right? How many of you do this? Right?
Create between 1 and 100 help desk tickets.
It's a great experience. It's a great experience. In reality, most of you probably don't operate all the services that you depend on when you're writing your application. So that's really what service brokerage is all about. One of the things that's kind of difficult about just database access for a developer is how do you get that password passed over to the dev from the ops team? And so we've got this really outstanding technology. I mean, I'm an operator. I provision databases for folks, and we've got this awesome technology.
Secure ROT26 encryption.
Yeah, it's super neat. So one of the things, while we talk about the Open Service Broker API and some of the work that's happening inside of the Kubernetes community.
I need that password, Chip.
Yeah. So Paul, in parallel, is going to be writing an application, and I'm in charge of provisioning the database, which I've already done. I got the ticket. Paul, I can't guarantee that any firewall rules are in place for this thing, because that's the network team's job.
Understood. I accepted the risks when I took the job.
Outstanding. And that's usually the way it works. I'm definitely not going to email you the password, though, right? Because that would be insane.
No.
Okay. All right. Let me get this written down here for you.
Get that note.
Right. All right. Cool. So, came over to Paul's cubicle. Here you go, buddy.
Finally, sweet relief.
Make sure you get that thing configured before we're done, all right?
I'm developing like crazy over here.
All right. It's the best Hello World app ever. There's got to be a better way than these Post-it notes, right?
We've been pounding cabbage into food processors with sledgehammers in my family for years. I don't think there is a better way. That's the only way.
Yeah, to each his own, but why don't we talk about some options so these folks have another option that they could decide and let them pick which one makes the most sense.
So here's where we get into some unavoidable, inconvenient territory. And thankfully, Chip had the foresight to come up with this maybe patent-pending system of the namespace that we're going to evaluate these nouns in is at the lower right-hand corner of the screen. So right now, it's Open Service Broker API, because we do have some naming collisions between Service Catalog, Kubernetes Service, Open Service Broker, etc.
Yeah. Also McDonald's service.
Yeah.
All the things. Cool.
Nuggets as a service.
Yeah. So we're going to talk about Cloud Foundry for a second, for a few seconds, just to give you some background on this API, how it evolved, what the need it was solving, and before we transition to the Open Service Broker API and Kubernetes. So back in 2011, Cloud Foundry was first open sourced by VMware, and it had 5 fixed backing services. Again, namespace to Cloud Foundry. What we mean by a backing service is actually, when you look at factor 4, the 12 factors. Anybody familiar with the 12-factor applications? Okay, so factor 4, stateless applications, persistence goes into a backing service. So that's the design pattern that Cloud Foundry was using, and that's the term for a service, right? So there was 5 of them. Now, for those of you that have written code before, generally you start with a fairly static implementation, and then you realize, oh my God, I just tightly coupled that thing really, really into the implementation details. Not much extensibility there. So in 2013, as CF was evolving, it got cleaned up. There's a V2 version of the service brokerage API, became much cleaner, and then eventually we added some asynchronous provisioning, and you'll see what we mean by that in a minute. All right, last point. Late 2015, 2016, we started having conversations with folks from the Deis project. We actually noticed that in their backlog was the implementation of the Cloud Foundry Service Broker API. Within that PaaS experience, it sat on top of Kubernetes. The folks at Google Cloud were poking around. And then we also, in talking with a lot of the Cloud Foundry end users, they were very clear that their data center is not going to be one platform. Now, all of you that might have a particular platform favorite, this is just reality, right? If you're from an enterprise, you understand that you have a complex environment. And so there's all kinds of crazy combinations that people wanted to have in place. Cloud Foundry plus Mesos, Mesos plus Kubernetes, CF plus Kubernetes, or maybe all three, right? Depending on the workload or the specific type of thing you were trying to deploy. And so figuring out how to make capabilities that are being exposed by different teams working on each platform work with the other platforms was actually very important to our users. So we created this thing called the Open Service Broker API. Today we've got committers on the project working on the spec from Google, Pivotal, SAP, Fujitsu, IBM, and Red Hat, and then many others that are starting to join the community, and we expect that will grow pretty significantly over time. This was created so that we could take the governance and the evolution of the API between platform and services and put it in a neutral place where different ecosystems, different commercial interests were able to collaborate and evolve it. It's a bit more complicated than just saying there's two distributions of an open source thing that they'll figure it out in the upstream, right? This actually becomes a bit more of a specification upstream. However, there's a little bit of a nuance there. One of the great things about the way that this group is operating is that this is not astronaut architecture. Any of you actually dealt with kind of specifications that are all on paper, no implementation? There's a general rule that we've got for the group, everyone has agreed to, that new features, new capabilities get implemented in a platform before it becomes part of the spec. Proves them out. So, okay, so before we move on though, you've been diligently working on your Hello World web app, right? Mm-hmm. That's outstanding, good. Did you get the database connected yet? Because I've got this ticket pending right now, and my boss is really getting on me.
I got distracted by this new JavaScript framework, and I lost the post-it.
Yeah,
Can I get another one?
Yeah, I mean, it's definitely time for a new JavaScript framework.
I mean, another post-it.
Yeah, all right. All right, hold on a second. Give me just a moment here. All right, this is the second one. It's a different password, Paul, because obviously you've left that at a coffee shop, so great job. Appreciate it,
All right. Finally, I can get back to work.
Yeah, excellent. All right.
So in Open Service Broker API, it's really simple. There's just 4 nouns that we really need to know. So a broker is something that offers a set of capabilities. We call those capabilities services, and the collection of those capabilities is called that broker's catalog. So naming collision there. A broker has a catalog. It's a set of services. Services are capabilities that broker provides. So as an example, a service might be database as a service, all right? And when you want to use that capability, you provision a new instance of it. So continuing that database as a service metaphor, when I provision something that I can use from that, I get a database. Now, that's all fine and good, but when I want to hook it up to my app, I need to bind to it, and a binding represents my desire to consume that instance somewhere. So just carry the metaphor through. When I bind to my instance, I get credentials that I can inject into my app somehow.
Cool. So let's just walk through how those nouns work in sequence. pretty straightforward, actually. The beauty of this API is how simple it is. You have a platform on the left, any type of platform. It's effectively the consumer. The end user is going to interact with the platform. This is about how a platform talks to a backing service capability. So step one, you get a catalog, right? Fetch, easy. Step two, a new user wants some of that. They want that database that you're offering.
Give me that database.
Yeah. All right, cool. So we can do it synchronously or asynchronously. I pointed out that asynchronous capability was added to the API later, but it turns out that's pretty important.
You might want to do some real work during provisioning, it turns out.
Yeah, no doubt, right? Last up, then we create binding, right? Again, that's the association. As far as the broker is concerned, it's basically providing unique credentials back to the platform, saying, hey, look, we know you've got a new application that wants to access this instance of the service. Here are the credentials for that specific application. Or I could even imagine it working in other ways where every node of a application that's communicating with the database could eventually get unique credentials. Make sense? Cool. And then, you can delete the things. That's pretty cool.
It is occasionally convenient to be able to clean up a database that you no longer use.
Yeah. The storage guys really appreciate that. Speaking of that, Paul, for real, are you done yet with the password?
Dude, in the time that we have been doing this presentation, a new framework has caught my attention. I have no clue where this Post-it note went. Can I get one more?
Yeah, good Lord. Okay, yeah, we can do that, Paul.
This is what it is actually like to work with me. And this is why we don't want to use help desk tickets like this forever.
Yeah, well, again, this is a highly secure approach, right?
All right.
Yep.
Let me just decrypt that over here.
Oh, sorry.
Oh,
go ahead.
Skip ahead.
Wow, now we're back.
The perils of two clickers.
Yes.
So where Kubernetes comes into play is that this API and abstraction that we're talking about, super powerful, right? We don't have anything like this yet in Kubernetes. So this is actually something that a number of folks have been interested, like Chip said, for a long time. We established a SIG, Special Interest Group in the Kubernetes community in September 2016. Made an incubator repo under Kubernetes Incubator Service Catalog in October of that year. And we've got folks like myself from Red Hat, from Deis, Google, and IBM. And we're working towards an alpha release that we want to be able to use against a 1.6 cluster, which is convenient since 1.6 was released yesterday. If you helped out with that, thanks a bunch. So the API, Kubernetes API that we surface from this looks a lot like other Kubernetes APIs in that it's intention-based. So what I mean by that is when you create one of these resources, it indicates your intent to do something. And then the Kubernetes catalog goes and tries to make sure that your intent is realized. So there's just 4 resources in this API. There's a broker that represents your intent to consume a particular broker in the catalog. Here's some naming collision again. Since we already have a thing called a Kubernetes service, we decided that we needed another name to represent services in the catalog. And as Mr. Jan Shafranek knows very well in the audience, there's a thematically similar resource in Kubernetes called service class, which represents a desire to use a type of storage. So, I'm sorry, did I say service class? Storage class. So our services in the service catalog are called service classes. And when you provision an instance of a service class, you make an instance resource. That represents your intent that you should get a new instance of the service class provisioned. Likewise, when you want to bind, you make a binding resource, and that represents your intent to make a binding to a particular application. So I'm going to talk more about those resources in the demo. It's way easier to show. Something interesting that I want to point out now is just a really high-level design. If you look at this, we've got an API server and a controller. Now this API server that you see on the upper left-hand corner of the screen is not the Kubernetes core API server. It's a new API server that reuses some of the API server pieces from Kubernetes, but it lives outside the core. We've got a controller that backs that, that's list watching the API and doing the normal Kubernetes thing that we're all used to, right? Where it's watching resources, it sees a spec type thing in a resource and tries to make that happen. Now, the controller is responsible for actually talking to the processes that implement the Open Service Broker API, and it manifests bindings back into the core API server. So some interesting things for the Kubernetes nerds in the audience. We might have one or two of those, right? This is the first example, or one of the first examples of extending Kubernetes with another tiny baby Kubernetes that grew up to be something else. And those of you that are interested in APIs might be wondering, how am I going to use these things together? Well, in 1.6, there's limited support for API aggregation, where you have a fronting proxy in front of the core API server and other API servers that presents a single discovery endpoint that you can use clients like kubectl against. In 1.7, this aggregator is going to be co-resident in the main API server process, which is going to make that API aggregation a lot simpler to use. So the last piece of this is that we need somewhere to put this data. One of the requirements that we have is that you shouldn't have an additional data store that you need to limit operational complexity. So our API server, you can either back it with etcd, and you can use the write key from the main etcd. If you're running Kubernetes in an environment where you don't have that write secret to etcd, you can actually back our API server with third-party resources so that your data goes ultimately into the core's etcd. You don't get another data store that can have skew with the core and gets backed up with the core's data. So I just can't keep track of where the mic is.
Hey,
but I also can't.
Paul, my boss just called me.
Yes.
I really, dude, the ticket's sitting there in pending status, and my SLAs are getting blown. Basically.
Did you tell him that I lost it?
I told him he lost it several times. Now he's getting mad at me. Have you got it sorted out yet?
I'm not seeing the problem here, but I trust this is a problem for you.
Do you have the password? Yes. The life of an operator. Look, do you have the app configured yet?
It's going to be ready, man. Don't worry about it. But I'm willing to try that better way.
Okay, do you have the password right now?
I don't.
You don't. Okay. You lost it. You lost it again. All right, hold on.
These frameworks are just coming out like crazy.
Did I not give it to you?
How is it in your back pocket?
Dude, I have no idea. All right, I'm going to get fired over this. So, all right, you're deploying Kubernetes. Show me what you got, man.
Show me what you got. All right, I think it's time to see a demo. All right, is my terminal big enough? Yeah. All right. So,
are the pillars in the room big enough for those of you behind it?
Give me more pillar. This is going to be a fun ergonomic experience over here. All right, so what I'm going to show actually is scaled back from what I planned. What I plan to show is that there are a bunch of brokers that folks in the SIG helped me get ready. Well, when I hooked them up to the catalog, I found that the catalog didn't actually work very well. So, sorry, Doug. Sorry, Ville. Sorry, everybody else. So what I'm going to show is basically an equivalent of like Post-it note broker. And for those of you that are interested in like the brokers that we've started hooking up, like, please do talk to, I'm going to just name some names real quick. Talk to Doug Davis. Doug, you want to put your hand up? There's Doug. Where's Ville? All right, Ville's behind the pillar. It's apparently at least big enough to completely obscure Ville from me. You can always talk to me about stuff we're developing at Red Hat. And Gabe is in the audience. Gabe, you want to put your hand up? Gabe at Deus. is happy to talk to you about his brokers. So,
and we should point out there's a whole bunch of brokers that exist already.
That's true.
That should work quite well. They come from the CF ecosystem, so you could get Google Cloud Services brokered into Kubernetes. You could get Azure Cloud Services brokered into Kubernetes. So that's the benefit of having this common API across all the platforms and services.
So let's check out what a broker resource looks like. It's pretty simple, right? Like, it has a name and it has a URL. Since this broker doesn't have any auth, it has a URL that says this is where I get to this. And if you see UPS broker in there like 3 times, it's just a product of how we happen to have this deployed. This is the cluster local DNS of this thing. This example broker is actually running in my local Kubernetes cluster. So when I create this thing, now I've put this API resource into our service catalog API server. And if I get it, you can see under status here, the controller's already picked up that I've created this thing. It's gone and fetched the service classes that this broker gives me. And it's ready to go. So let's see. Why don't I list the service classes? And hey, there we go. User provided service. Basically, this is kind of like a post-it note. You can put credentials into it when you make an instance of it, and it'll give them back to you when you bind. Now, I want to just note before I go any further, you'll notice I'm actually in my service catalog repo now, and the resource that I made is in contrib examples walkthrough. This is our walkthrough for service catalog, and one of the reasons that we thought it would be good to demo this is that you can all go and try this out and do the exact same demo as I'm doing up here. So note that I'm going to make an instance of this service now. And let's talk about what this has. So note, this instance is namespaced. This resource is namespaced. Instances live in a namespace. Its spec is the name of a service class. Brokers and service classes are global resources. And this plan name is referring to the service plan that we are going to select from this service class. Plans they're not API resources, but they're API types. A plan is basically a tier of a service. So, for example, your service might have like a free tier. It might have if we're talking database as a service, maybe your free tier is like, little play thing that you can use, but it doesn't hold that much data. Maybe when you go up to the silver tier, you get like a table space created for you in a multi-tenant database somewhere. And when you go up to gold, you actually get a new database process created for you that you don't share with anybody else. So this user provided service just has one plan called default, and we're going to use that one. So when I create this, I created it now. Let's take a look. Let's see if our controller did its job. All right, check that out. We've got a condition on there that says it's ready. The controller's gone out and told this service broker, give me a new instance of this service, and it's ready to use. So that means I can bind to it. Now, those of you that are familiar with Cloud Foundry, can I get another show of hands? Okay, we got some Cloud Foundry users. In Cloud Foundry, when you bind to a service, you get this environment variable called vcap services that has JSON representation of the credentials that you got back from the bind. Now, in Kubernetes, we have a couple different mechanisms that you can use to get things from secrets and config maps manifested into your app. You can get them in environment variables. You can get them in volumes. And so what we're going to do right now with this state in the repo that I'm demoing from is we're just going to create a secret. And how we can use it is up to us. So I'm going to make a binding really quick. Let's check out this. binding looks pretty simple. It's just a reference to an instance. Note, bindings are namespaced. So instances and bindings are namespaced. And right now you can only bind to an instance that's created in the namespace of the binding. One of the future things we want to do is be able to do cross namespace references, but there's some expensive, relatively speaking, precedent to establish in Kubernetes to do that. So in our MVP, you have to have the binding in the same namespace as the instance. So that's what we want to bind to. Where we want to put it is in a secret named mySecret in this test.ns namespace. So let's create that.
Before you press enter, Paul, I got to tell you, I'm getting excited. I might not get fired if I could show this off.
Well, I tell you what, if you don't get fired, beer's on you.
Outstanding. Outstanding.
Now, before I do this, I want to show nothing up my sleeve. Let's see which secrets are in my namespace. I got a default token there. Don't have my secret pre-created or anything. So when I create that binding, oh, look at that. We had the controller saw I made a binding. It went out and told the service broker to do the binding. It got back some credentials, and it made the secret in the Kubernetes core API that I can now use in my application. So those are the mechanics. I'm not a fan of like flashy demos. I don't want to get hung up on a particular technology. I just want to show the plumbing. That's my plumbing.
You were thinking about making your terminal all rainbow, though, so you do like Flash.
I was,
let's
yeah. We can see that. So let's do this. Let's I do not recommend this position that I'm in now. It is not fun.
See, that's much better.
Yeah. All right. Better. That's a little bit more fun for the developers in the room.
He's lying when he says he doesn't like Flash.
All right. So check this out. We've got a condition on here that says, I'm ready. I injected the bind result. That's what we get when our secret gets created. So that's the gist of it. Next steps, getting to alpha. Some of these things have actually happened already, and I haven't taken them off the slide. But so we noticed that we got a secret created in our namespace. That's good, right? But that means that I have to know that it's there to be able to use it. And it also means that I have to like put that knowledge into every place that uses it. Now, luckily for us, Jess Frizzell in 1.6, Jess, you in the audience here? Okay, she might not have made it. All right. In 1.6, we implemented a new core API resource in the settings API group called pod preset. Now, pod preset is we've got the what do I want to use, where do I put it? Pod preset is the how do I want to use it. So part of pod preset's spec is a subset of the pod spec. You can say, I want to use this thing in environment variables. I want to use it in volumes. I want to mount the volumes into containers at this point. And then that's the how do I want to use it. Who do I want to use it? We specify in a label selector. So you can create a pod preset. You will be able to create a pod preset once we finish rebasing a catalog on Kubernetes 1.6, which is a lot of fun. You'll be able to create a binding that has the what do I want to use, where do I want to put the data, how do I want to use it, and who should use it just in one object. What this means is that you will be able to get that automatic injection after the pod preset resource is created in pods that match the label selector, which I think is pretty cool. So we talked a little bit about the API aggregator already. That's going to be co-resident in the API server process in 1.7. And this is important to us because we're building this thing outside the core. But it's also important to anybody in this audience that wants to build an extension to Kubernetes outside the core. So once we have those things, we need a way to make sure that like authn and authz work without having to set it up twice. The service catalog API server will delegate back to the core API server for authn and authz. And then there's some other integrations with the Kubernetes core that those of you that know Derek Wayne Carr from the Kubernetes community, he likes to call it the Kubernetes bow, just to make the experience like exactly what you would expect when you use a Kubernetes API. So that's alpha. After alpha, we've kind of hinted at some of these things. So like I said, brokers and service classes aren't namespaced. That's convenient for us from an API standpoint, but we still need some kind of mechanism to make sure that like the right people can see and use the right services and not services that they shouldn't be able to use. We also want to have cross namespace bindings, and then there's a number of enhancements to the Open Service Broker API that we're proving out right now that we expect to ripple back into this API, like schema for parameters that you can give to bind and provision output schemas. So you could do things like when you do a binding, you get back credentials, you get coordinates, you get config. We want to put those things in the right Kubernetes primitives, that kind of thing. And that's basically the short version of the roadmap. We got some time, it looks like, for questions, or not. I can't tell because my clock's in the wrong time zone.
I think not.
I think not.
Yeah.
We'll be around. There's folks in the SIG that are around that raised their hands earlier. OpenServiceBrokerAPI.org, GitHub.com/Kubernetes Incubator Service Catalog. Thanks a lot, everybody, for coming. It's been a pleasure.